Hi students. Today I'd like to show you how to use StatCrunch to do hypothesis testing and establish confidence intervals. I'm going to be using something called the Massachusetts School Data Set, where we have many school districts about in and around the Boston area. We've identified them as either cities or towns and the county they're located in, and various aspects of the population. And the variables of interest are SAT reading, SAT writing, and SAT math. So for my first illustration, I'm going to compare the SAT math scores in districts that are towns versus districts that are cities. So to do that, I'm going to go under Stat, T-Stat. This would be two samples with data. The variable of interest is SAT math. And I'm going to be comparing cities and towns. So I'm going to build this by picking the community, because that's what I'm looking at, the community, and I'm going to double click on that. And then I'm going to identify which community, the one that equals, and I'm going to go down here and I get to pick between city and town, and I'm going to have the towns be my first sample. And so when it says towns, I'm going to hit add. And then I'm going to say, okay. So I'm looking at it, and the first sample is the SAT math scores in communities that are towns. The second is going to be SAT math scores in, I'm going to build this, communities, equals, and I'm going to go down here, and this time I'm going to pick city from the drop-down menu. I'm going to pick city. And I'm going to add it, and I'm going to hit OK. So I'm comparing SAT math scores in cities and towns. I'm going to compute it, and here we have the results. The t-statistic is very large, and it is very significant at the 0.0001 level. So towns were my first community, and cities were my second community. So I'm going to go over here and try to explain what this means. It's a significant t-value. That means that I can conclude that the mean math SAT scores are significantly higher in school districts that are towns, community 1, than school districts that are cities, community 2. And I want to state how certain I am of that. There's only a 0.0001% possibility that I did the wrong thing in making that statement. So I'm going to go back, and I'm going to go under options, and I'm going to edit, and I'm going to change the hypothesis test to a 95% confidence interval. And here's my results. Lower boundary is about 34. Upper boundary is about 60. Let's see what that says. With 95% confidence, we can report that the mean math SAT scores for school districts that are towns are between 34 and 60 points higher than the mean SAT score for cities, for school districts that are cities. And notice that I use the word points because that's how we identify, or how we, that's the units, so to speak, of SAT score. So now what we're going to do is we're going to re-examine our data and we're going to do a paired t-test. This time we'll be pairing our data on the individual school districts, and we'll be comparing SAT math scores with SAT reading scores taken on the same school district. That's the pairing. So under STAT, we're going to pick t-stat, paired data. Column 1 is going to be SAT math. Column 2 is going to be SAT reading. And then we're going to do a hypothesis test, a paired t-test, and we're going to see that the t-value is very large and it is very significant. And our sample 1 was math, our sample 2 was reading. So let's put that into words. The mean math SAT scores in school districts in the Greater Boston area are significantly higher than the mean SAT reading SAT scores. And the probability of error in that statement is only 0.0001. Very small. Let's go back and change this to a confidence interval, a 95% confidence interval. And here we have our boundary values, 10.8 and 14.68. Let's put that into words. With 95% confidence, we can report that the mean math SAT scores for school districts in the Greater Boston area are between, I'm doing a little rounding, 11 and 15 points higher than the mean SAT reading scores. And finally, I'd like to give you an example of where there is no significant difference. I'm going to be comparing the SAT math scores in Essex County and Barnstable County. To do that, we're going to go back to StatCrunch, and this will be 2 independent samples with data. SAT math is the variable of interest, and the county, we're going to be looking at first, which county? We're going to be looking at Essex County, so the county equals, and I'm going to pick Essex County, and I'm going to add it and say OK. And then in the second sample, I'm going to pick SAT math, but now we're going to build this to be that the county, click it, equals, and now we're going to pick Barnstable from the drop-down menu and add it. Oops, we only have to add it once. So let's back this up. And we're going to say OK. So we're comparing SAT math scores in Essex and Barnstable County. Compute. The p-value is not less than 0.05. The t-value is small. Let's put that into English. So we have a p-value that is not less than 0.05 and a t-value that is not significant. So what does that mean? We cannot, using this data, establish a significant difference between the math SAT scores of students in Essex and Barnstable County. Please note, I am not saying they are the same. I'm simply saying we cannot establish a significant difference. That is very important. Maybe with a different data set in another year or with more students, but this data does not allow us to establish a significant difference. When we look at the confidence interval has a negative lower boundary and a positive upper boundary. 0 is included. What does that mean? It means, again, we cannot with 95% confidence, establish a significant difference between the SAT scores, the math SAT scores, of students in Essex and Barnstable County school districts.